Hello everyone. In this video, we're going to be dealing with a polynomial equation. We are given x squared minus 5x plus 1 equals 0, and we're supposed to evaluate x squared divided by x to the fourth plus 1. First of all, let me tell you that we're expecting to get a numerical answer from here. So I'll be presenting three methods. Yes, not two, but three. And let's start with the first method, because I know if I don't, then some people will be mad. Anyways, all right, just kidding. So first method involves brute force, obviously. X squared minus 5x plus 1 is equal to 0. If you solve this quadratic equation, x becomes 5 plus minus the square root of 21 over 2. Let's go ahead and use the positive version, 5 plus root 21 over 2. Now, would it matter if you use the other one? It wouldn't. You can check it out. So this is x. Let's go ahead and square both sides so we can get x squared. I did the work for you, so to save you the trouble, from here x squared becomes 23 plus 5 times the square root of 21 over 2. Great. I also need x to the fourth power, so let's go ahead and square this one more time. And again, to save you the trouble, I squared it for you, and it gives you 527 plus 115 times the square root of 21 over 2. So we got x squared and x to the fourth power. Why not substitute, right? We're supposed to evaluate x squared over x to the fourth plus 1. And I'm going to substitute 23 plus 5 root 21 over 2 here. And x to the fourth will be replaced with 527 plus 115 root 21 over 2. And then I have to add 1. Now, if you make a common denominator, obviously the 2's are going to cancel out. So I can go ahead and write it like this. And the bottom one is going to give me, after making a common denominator, multiply 2 by 1, add 2 to 527. You're going to get 529. Plus the radical is going to stay the same. Okay, so that is the expression I'm looking for. And it's numerical, right? But we can make it better. It is definitely numerical, but it's kind of too radical. So here's what we're going to do. Having known that, hopefully you do know this, 23 squared is 529. I can kind of take out, and this is 5 times 23, and this is 23 times 23. So we can take out a 23, and inside the parentheses we get 23 plus 5 times the square root of 21. How nice, right? And we can simplify this. Go ahead and cancel out, and you end up with 1 over 23. Using the first method, which is kind of brute forcey, but it gives you the answer anyways. So let's go ahead and do the second method. And again, if you try, and you can definitely test it for yourself, instead of using this one, it would give us the same thing if I use this one, because everything would change accordingly, and at the end you're going to see that you get the same answer. But you can definitely go ahead and try it out. So let's go ahead and talk about the second method. So to remind you what the problem was, x squared minus 5x plus 1 equals 0. And we're supposed to evaluate x squared divided by x to the fourth plus 1 numerically. So the second method involves the following. I'm going to isolate x squared, write it as 5x minus 1. Since this is a polynomial, I can just, evaluate higher powers by using this fact that x squared equals 5x minus 1. And since I need x to the fourth power, it would make sense if you squared both sides. And if you do, you're going to get 25x squared minus 10x plus 1. And then x squared obviously can be replaced by 5x minus 1 one more time. So x to the fourth can be written as 25 times the quantity 5x minus 1 minus 10x plus 1 from here. And from here, x to the fourth becomes 25 times 5x, which is 125x, minus 10x is 115x, minus 25 plus 1 is minus 24. So I got an expression, a linear expression for x squared, as well as x to the fourth power. So why not substitute everything here? Let's go ahead and do it. And this should be familiar to you. X squared is going to be replaced with 5x minus 1. X to the fourth is going to be replaced with 115x minus 24 plus 1 is going to give us minus 23. Make sense? Hopefully it does. Now we can go ahead and do the same thing. Factor out 23 And now we can write this as 5x minus 1. 5x minus 1 cancels out, leaving us with 1 over 23 as the answer, right? So based on the given, this quantity equals 1 over 23 as we found out before. So the first method, just to recap real quick, involved solving for the quadratic using one of the roots, doesn't matter which one, and plugging it into x squared and x to the fourth to evaluate numerically. And then since we have everything numerically, we were able to substitute, and at the end we were able to simplify, and we got 1 over 23. Second method kind of involved a more polynomial approach where we isolated x squared and then used it to find x to the fourth in a linear fashion, and then plugged in both, and at the end it simplified. Let's go ahead and take a look at the third method now, which is obviously my favorite. Saved it for the last. And my third method is going to involve the following, and which is really cool because that also kind of explains how we get a numerical answer from this. Okay, because you don't always get a numerical answer. All right, so here's what I'm supposed to evaluate, and here's what I'm going to do for the third method. All right, since I have this expression, I can go ahead and isolate 5x or add 5x to both sides. And then here's the thing. Notice that if I divide both sides by x, I'm going to get something super duper nice. First of all, I'm going to get a numerical answer on the right hand side, and on the left hand side I'm going to get something nice, which is x plus 1 over x. Since x does not equal 0, I can divide both sides by x definitely, right? Now why is this significant? Because if you look at this expression, that could also be turned into something that uses this. How? Let me explain. I'm going to go ahead and manipulate this a little bit. Like how? I'm going to go ahead and factor out an x squared here. And inside the parentheses, of course, this is kind of like a forceful factorization because it's not a common factor, but we're going to make it a common factor. And we're going to get the following. Since x does not equal 0, this cancels out, leaving us with this. So this is what I'm trying to evaluate, right? If I can find x squared plus 1 over x squared, then I got the answer. But what is it? Given x plus 1 over x, we can go ahead and square both sides, right? And that's going to give us the following. X squared plus 1 over x squared plus 2ab is going to give me 2 equals 25. If you subtract 2, you get x squared plus 1 over x squared equals 23. And if you go ahead and remember, this is what we were looking for. If you go ahead and substitute that here, then you'll get the answer as 1 over 23. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.